Hi, I'm Dr. Irene Burkhalter with West Virginia University High Performance Computing, and today we will be talking about array jobs in Slurm. This is a feature of the Workload Manager that can be used to improve your workflow by allowing you to launch many similar jobs at once with only one job script. The ideal use case for an array job is when you need to launch multiple jobs that are nearly identical except for one input parameter. The jobs launched will all have the same directives, so it's important to make sure that all the jobs require the same resources like number of cores, amount of memory, and wall time. We'll explore this further using a simple example of trying to find the roots of a function with different initial guesses. In this example, we'll try to find different roots of the sine function using the Newton-Raphson method, which is a root-finding algorithm that uses an input function and its derivative to successfully make better and better approximations of the function's root with each step. Because the sine function has multiple roots, this algorithm will return different values for the root depending on the initial guess. Specifically, the roots of the sine function are multiples of pi, such as negative pi, 0, and pi, and the algorithm will return whichever of these values is closest to our initial guess. We'll now turn our attention to a simple Slurm script that will submit a small job to the queue to execute the Newton-Raphson method on the sine function. In this script, we can see the usual directives that we need to use, such as specifying the number of nodes and CPU cores that we need, the wall time of our job, as well as the amount of memory that we'll be allocating. Remember, these resource allocations will be identical for each job in the array. We can also see the code that we'll be using to run our root-finding algorithm. In order to turn this job script into an array job, we must first add the sbatch array directive. This takes a range of numbers as an input parameter. Here we use 0 through 6. These numbers will be used as the task ID for each job and can be accessed within the script using the Slurm array task ID variable, as we will see in a moment. We will store the different input parameters that we want to use in a bash array. We will then specify the initial guess for the algorithm using that bash array and the Slurm array task ID variable. Now that we've made all the changes we need to make, we can save this file and use sbatch to submit the array job to the queue. Now that all of the jobs have finished, we have standard Slurm output files in the directory to look at. If we look at what's inside of these, we can see that for each initial input guess we used, we found the corresponding closest root of the sine function, showing us that we did in fact code our array job correctly. Thank you for watching, and I hope that you find this useful in your research.